All right, guys, so let's take a look at lesson 8.1, continuing on. In this portion, we're going to actually start graphing quadratic functions. So we know that a quadratic is ax squared plus bx plus c. What we're only going to be focusing on right now is just the ax squared portion. Okay, so we're not going to have any of the bx plus c. We'll add those in later, but we're just going to see what happens because each of these letters, this a, this b, this c, and we use those in factoring, they each have their own role. Well, they each have their own role in how the graph looks as well. And again, relating it back to what we're maybe a little bit more familiar with when we have y equals mx plus b, this m has a big role in how the graph is, and so does this b. It tells where it crosses the y-intercept. So the m was our slope and the b was our y-intercept. Well, similarly, a, b, and c have a role. Okay, so rather than reading all of this, because this is true, it's great reference, but it's a little bit much to take, I think it's easier when we can see it. So what I have up here now is Desmo's screen, and what I want you to look at in green is the parent function, y equals x squared. Okay, so that one's not going to change. That's the parent function. It is a parabola. It's facing up. It's like a nice smiley U. And now what I put below it is ax squared, which means that this a can be any number. A is a constant. Okay, so a can be 1,000,000 x squared, or negative 1,000,000, or negative 500 billion. You can obviously get the idea. It can be anything. Now, to get an idea for what happens to it, though, there's this slider in here. Okay, so I'm going to put it first at just 1. So whenever a is 1, that's the same as 1x squared, or just the green parent function like we have. And notice if we look at our graph, they're one on top of each other. Now let's see what happens whenever a gets bigger. So whenever I see, I'll go up to 2. When it's 2x squared, look at that. Again, my green is the original. That graph got narrower, right? That red one, it's narrower. And now whenever we go up to 3, it keeps getting narrower. The higher I go, and this little slider only goes up to 10, but it keeps getting narrower and narrower and narrower and narrower. And what that is called is a vertical stretch. Okay, it's kind of like if we were in school, I would bring in a jump rope and put my foot in the middle of it. Think of a jump rope holding both sides of it, and it makes a parabola. But if you put your foot in the middle and you pull it up and you keep pulling your arms up, it's going to stretch that parabola up, and then in doing so, it makes the sides of it tighter, and that's why it gets thinner. Okay, if that it's hard to show you that talking through it, but that's what that is there. Okay, now let's see what happens whenever we get an a value that is less than 1 and greater than 0. So now, go back to 1, here's where we are. Now whenever I start getting decimals, look what's happening. My red graph, it's getting flatter, basically. This is called a vertical, shrink. It's getting like I said, flatter. It's like I'm letting those sides of the jump rope down. It's shrinking down. And this has to do with the y values. The y values are essentially shrinking for each coordinating x value. But then let's see what happens whenever we go to 0. Just a flat line, because 0 times anything is 0. So it'd be 0x squared, so y equals 0. It's just straight across. But now the negatives, where does it go? Oh, with the negative, look, it flips upside down. It's kind of like a frowny face. Okay, so a negative moves it upside down. So this is a lot to take in. I keep saying that, but it is. So we're just going to piece by piece graph it. Now they have all of that kind of labeled out here. It says when a is greater than 0, that just means when we have a positive number. So when it's decimal, when it's between here, we saw that that's when it got kind of wider out, and that's called a vertical shrink. It's getting wider, okay? And when we get into some points, we can explain why that is more. But then we have whenever it is greater than 1, that's whenever it gets narrower, as we saw, like you see with this green line here. It's called a vertical stretch, okay? And whenever a is less than 0, that's whenever it's a negative, and notice everything is upside down. So you have the same thing. A decimal is called a vertical shrink, and then a whole value greater than 1, but in this case -1 is called a vertical stretch. Okay, so there's a lot of components there. One thing that I'll keep in mind is if it's a positive a value, so if you have a positive ax squared, look at this, doesn't that kind of look like a smiley face if I put two eyes in? And if I have a negative, well, a frowny face. So negative is sad, and positive is happy. So maybe that'll help you just remember just in the positive negative sense of it. All right, let's go ahead and start graphing. Okay, so they're going to ask us to graph the original and then compare it to the graph of f of x, the parent function. So I'm actually going to make myself a table here. This is going to be x, and then this will be f of x, my parent function. And let's just fill that in first. So I'm going to use these table values, -2, -1. Actually, let's not use -2, -1. Let's use -4, sorry. -4, -2, 0, 2, 4. And that might not always work, but for right now, that should be good. Okay, so what I'm going to do here is -4 squared is -4 times -4, which is 16. -2 squared is -2 times -2, which is 4. 0 squared is 0 times 0 is 0. 2 squared is 4, we know that one, and 4 squared is 16. Okay, so now I'm going to pull in, and let's plot that actually. So my point here is my first order pair is -4, 16, -2, 4, 0, 0, 2, 4, and 4, 16. Okay, now you can pick any points. I'll tell you which ones to do, like if we're doing an open-ended assignment, but this is going to be a little bit off, but that's -4. I'm going to go up 16, and I think that goes 4 above here, so that's a little bit off the graph, but that's okay. So this is my first point, -4, 16. All right, next I'm going to do -2, 4, which is right here. And then we have 0, 0, and then 2, 4, +2, 4, and then 4, 4, 16 up here. Okay, so this is my nice parent function. That's the original one, okay? Now I'm going to add in the one they're asking me to do. Now, the nice thing is we're using a table, so I don't really have to do anything special. I just follow the rules of PEMDAS. So this is going to be 2 times -4 squared. I'm using PEMDAS, I have to square the -4 first, so I get 16. So it's really 2 times 16, which then is 32. Obviously, it's going to be way off the graph. And then I'm going to do 2, because that's the function, 2x squared. 2 times -2 squared. -2 squared first is 4, so it's 2 times 4, which is 8. All right, and then 2 times 0 squared. 0 squared first. Remember, we're following PEMDAS here, so you have to do your exponents first. 0, and then 2 times 0 obviously is 0. 2 times 2 squared, so I do this part first. So it's 2 times 4, which is 8. And then lastly, 2 times 4 squared, which is 2 times 16, because 4 squared is 16, and I get 32. I should see this like matching for these first graphs in this lesson. That should always be the case. All right, so obviously -432 is going to be way off the screen, way off the graph. I'm just going to go up here. Then we have -2, 8. That one we can graph. 2, 4, 6, 8, about. Those are really hard to see. I'm going to think it's right here. 0, 0 falls again. 2, 8. And then lastly again 4, 32. I went up to, I counted by -4, -2, 0, 2, 4. I probably could have kept it where it was. But anyways, my graph now looks like that. All right, so that's what happened to it, and it makes sense. First of all, it was positive, so it didn't flip upside down. It's still a smiley face, but it got a lot narrower, and that's known as a vertical stretch. Okay, and you could even say by a factor of 2. And what that means is, vertically, my y value, look what happened to my y value. My y value here stretched by, was 16, it turned into 32. It was 4, it turned into 8. It multiplied by 2. That's why it's called a vertical stretch by a factor of 2. All right, so that compared it. Let's move on. And I have these ones set up. We're just going to practice some of them, okay? So here I have already done it. I did it with -2, -1, 0, 1, 2. I'm going to quickly just sketch that in. That's the parent function. That's going to be the same every time. Now, I used here -2, -1, 0, 1, 2. So that was like -2 squared gave me 4. -1 squared was 2. 0 squared is 0. 1 squared is, sorry, 2 squared is, oh wait, these should be 1, 1. Sorry. So let me erase that. Let's just fill this in together, okay? -2 squared is -2 times -2, positive 4. -1 squared is -1 times -1, positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, that's more like it. -2, 4. And then we have -1, 1. Then we have 0, 0, 1, 1, and 2, 4. And these graphs are on here. If you did happen to print it, that's hard to see those. I remember putting them on, and it was just so that we could get some larger numbers, but obviously it's hard to see. All right, let's go ahead and fill in these values then. And you're welcome to pull out a calculator if you need it, but we should be okay. So we don't want to rely on that. -1/3 times -2 squared. Remember, we do PEMDAS first, so we're doing this portion first. So it's -1/3 times 4, and that gives me -4/3. Okay, so that's my first output. Then I'm going to do -1/3 times -1 squared. Again, I do this first. -1 times -1 is positive 1, so I have -1/3 times 1, which is -1/3. 0 is always nice. -1/3 times 0 squared. Well, that's 0. Zeroes everything out, but I'll still work it there. And then we have -1/3 times 1 squared. And we should again see that like relationship. This is going to be -1/3 times 1, or -1/3. And last but not least, -1/3 times 2 squared is -1/3 times 4, which is -4/3. Okay, so I know it's a little sloppy, but my first point I'm going to plot, and the way I'm looking at this is my x value of -2, my y value is -4/3. And if you even want to write that, -2, -4/3, that's my first point. Then I have -1, -1/3. Then I have 0, 0, 1, 1, sorry, and still -1/3, and then 2 and -4/3. So again, the way I got these was here to here. My input, my output, my input, my output, my input, my output. Okay? All right, so let's graph this one. I'm going to be approximating it, obviously, but -2, -4/3. Well, 4/3 is 1 1/3, so -2 down here, and again, obviously, that's not very accurate, but we get the idea. -1, -1/3, so -1 and -1/3, 0, 1 and 1/3, and then 2 and 1 and -1/3, and 2 and -4/3. So this one's going to look more like this. So first of all, I see it's upside down, which I could have already figured out because it was a negative. So that I see this is a reflection in the x-axis. All that means, and I'm just telling you that just in case you ever come across it written like that, that means it just flips over the x-axis. You could say it's upside down too. It's not very mathematical, but it works. And then it got wider, okay? And again, that's because this first number, 1/3, is between 0 and 1. So that means this is a vertical stretch, or I'm sorry, a vertical shrink. So if it's a small number, a decimal, it's a shrink. If it's a big number, greater than 1, it's a stretch. Vertical shrink by a factor of 1/3. And there you have it. Okay, so that's the comparison portion, what we're looking at there. Okay, I'm going to make one more video that just goes over the next 4 if you feel like you need more practice. If you feel like you're okay, you can give a go at the homework. Okay, thanks guys.